Okay, so I am showing you a new reaction here, a reaction of dinitrogen gas plus 3 hydrogen gas molecules giving you 2 ammonia gas molecules and heat. This reaction is a very famous reaction. It is called the Haber reaction, and the reason for this is because we are fixing nitrogen here. If I were to calculate the delta G of this reaction, I can go straight to the delta G of formation tables and I can find the delta G of ammonia, and I see there that it is minus 16.5 kilojoules per mole. So if I want the delta G of the reaction, it is simply the 2 moles of the ammonia times the negative 16.5 kilojoules per mole minus 0 added to 0 for the nitrogen and the 3 hydrogens. And if I calculate that, it's equal to minus 33 kilojoules for the reaction. And that tells me that this reaction is a spontaneous reaction. I can do the same thing for the delta H of reaction, the enthalpy of reaction, and if I do that, I come up with a value of minus 92.2 kilojoules for the reaction. Lastly, the delta S. Again, I could go back to the appendix G and find out what the delta S for this reaction is, but I could also just kind of take a look at this reaction and determine whether or not the delta S is positive or negative. And what I see here is that I have 4 gas molecules as reactants going to 2 gas molecules as product. And so that means I'm going from a lot of entropy, a lot of disorder with those 4 gas molecules, to less entropy. So I am heading in the negative direction. So at least I know that delta S on this one should be negative. But there's also another way to solve this problem. Remember that delta G equals delta H minus T delta S. And when I do that, if delta G is a value of minus 33 and the delta H is a value of minus 92, and I subtract from that minus T delta S, and if I solve for delta S, I'm going to add 92 to both sides. That'll give me 59 is equal to minus T delta S, or negative 59 equals T delta S. T is always positive, and so if that's the case, delta S must be negative in this particular problem. So a couple of ways of looking at it, and I'm not getting the exact value for it here. I could do that if I were to actually, if I knew what the temperature was, but that was sort of beside the point.